All right. We having a good time so far here at the PowerShell Summit? Yeah? All right. Before I start, did anyone go to Thomas Raynor's session in here just before? Yeah? A couple of people. So you're all ready for some more C#? All right. What Thomas was showing you before was basically taking the PowerShell API, right, system.management.automation, this entire C# namespace, and building some cool PowerShell commandlets on top of that. We're going to take it a step deeper, and we're going to look at a very specific subsection of the API itself. We're going to talk a little bit about how the language itself is passed and interpreted. And then we're going to see if we can modify that behavior. Does that sound interesting? Cool. All right. So the title of this talk, Parselmouth, is an allusion to an ability that Harry Potter has. He's a parcel tongue, meaning that he can speak to snakes. And this gets him into all sorts of trouble, but in the end, it helps him save the world. And I couldn't remember parcel tongue, and I was pretty tired when I submitted this session, so it became Parselmouth. Sorry about that. It doesn't really matter, because this is going to be the last Harry Potter reference of this talk anyways. I'm also not sure you'll be able to save the world, but you might get into trouble if you dig deep enough into this. All right. So my name is Mathias. I'm from Denmark. I work at a company called Booking.com. You might have heard of it. We sell hotel rooms. I work in the security department there. We're not going to talk about security today. We're only going to talk about PowerShell, the language. I am obsessed with PowerShell. I picked it up around version 2 about 10 years ago. I was working at a hosting company where we had a lot of new Exchange 2010 was the big enterprise product at the time. And if you were an administrator of an Exchange organization at the time, you had to learn PowerShell. There were things you simply could not do without it. And even if you opened up the Exchange Management Console and you executed some action, it would take a little longer, and you would see at the bottom, it would actually execute PowerShell in the background. I kind of got hooked on this, because it meant that I could start codifying all of the things I would do as an administrator, right? Instead of RDPing into a box, clicking on some things, doing this all over again, I could write a couple of lines of scripts, and I could repeat this, right? So if I had a customer with one server, okay, fine, I could RDP in, click, took 10 minutes. If I have a customer with 1,000 servers, I'm not gonna RDP into 1,000 boxes, right? So PowerShell, kind of fantastic. So I get deep into this. My work has kind of taken me away from PowerShell as my primary thing I do, which is why I come to conferences like this, so I can kind of indulge in my favorite programming language. Right. So the agenda for today, very simple. We're not going to do a lot of slides. This is going to take 5, maximum 10 minutes. We're just going to give like a very short historical context. I see there's a couple of PowerShell team members here, or former team members. They're probably going to correct me along the way. We're going to have a little bit of a look at the system.management.automation.language namespace and how the parser, kind of the first part of the language engine in PowerShell, is exposed and how we can interact with it. And then we're going to write a new operator. Operators are these things that we can apply to operands in PowerShell, right? So you can say 1 + 1, plus is an operator. You can say array contains something, dash contains is an operator, right? And so what we're going to do by the end of this talk, we're going to implement a whole new operator that you have never seen in PowerShell before. In order to do this, we're going to review the existing implementation of an operator, as everyone can read in now open source PowerShell, PowerShell Core. We're going to come up with a short plan of how we're then going to implement our own operator, and then we're just going to go ahead and do it. This is my standard disclaimer. I have no idea what I'm doing. This is all presented as is. All right. Why are we here? It started somewhere. In 2002, Jeffrey Snover wrote this thing called the Monad Manifesto. Right? And the Monad Manifesto laid out kind of a radically different approach to how we might want to administer our Windows servers. And this is kind of cool, right? Next big step, in 2006, I believe, the first generally available version 1 of PowerShell came out. I remember someone showing me this and doing this start service or stop service, and I said, this is stupid, right? I could just open services MSC. I didn't get it. Then in 2009, alongside the release of Windows 7 in 2008 R2, we got 2.0, which shipped as a component in the operating system, right? So all of a sudden, everyone who installs Windows has access to PowerShell 2.0. There's another kind of magical thing about this release, and that is that it kind of became a fully fledged scripting language, right? All of a sudden, we could sit down and we could write these commandlets without having to know or write C# or VB.NET. And this is kind of where I jumped on the bandwagon. PowerShell 3.0 I want to point out because as my understanding from anecdotal evidence, this was kind of a major refactor of the language, and I think we're going to see that in the way the parser behaves. 4 we're going to skip over, not because I don't like DSC, but that was kind of the only highlight of that release. In PowerShell 5.0 in 2016, we got a bunch of new language constructs for defining types, namely classes and enums, and again, kind of expanding the surface and applicability of the language. And then in 2018, after 2 months of kind of beta testing, alpha testing, community input, stabilization, PowerShell Core got released open source for the win, right? This was magic to me because I could go to GitHub, and some of you might have had this experience, right? You could go to GitHub and you say, why is PowerShell being stupid, right? Why is it having this weird behavior? You know what, let me just look at the source code, And then finally, last year, I went to this very conference for the first time, great experience, and Mr. Thomas Rainer himself did a super cool crash course in ASTs, the abstract syntax tree, which is kind of an intermediary representation of the PowerShell language. And so I saw this and I thought, oh, this is really cool. I can come to this conference and I can talk about these nerdy language things and people are not going to rip me to shreds. So, okay, I'm going to come back next year, and so here I am. So thank you, Thomas. Right. We're going to talk a little bit about the PowerShell language runtime, or the PowerShell language infrastructure. This is going to be like a very condensed, simplified version. But basically what's going on here, this is how I imagine from having used it and from having talked to some of the people who implemented it. This is how I imagine that version 2 looks like. We have a script or something that we put into the command liner. And so what happens to this when you press enter, right? What happens is that this gets fed to what you might, in a compiler language infrastructure, call the front end. There's something called a parser, which contains a tokenizer. Tokenization is the first step, which basically means that you have something called a lexical analyzer that reads forward through your script and tries to recognize the weird squiggly characters. What do they mean, or what could they mean? It passes this list, this forward read list of tokens back to the parser. The parser then tries to see if it can kind of develop some context around all of these tokens and imply some meaning. Like, does this fit with the grammar of the language? Does this make sense? Do I need to throw an error, or can I move forward in trying to execute this? Next thing that happens, and this is kind of where the AST comes into it, the parser outputs an abstract syntax tree. And an abstract syntax tree is basically a hierarchical representation of the elements of the script that you just put in, right? So in this case, I'm not sure these are the actual type names of the AST elements, but at the very top, at the root level, we have this script, right? There's some stuff in there. The script has 2 statements, line 1 and line 2. The first statement is an assignment with a variable on one side and some expression on the other side that's going to get stored in that variable. And then the second statement contains a single pipeline where we pipe this variable expression to a commandlet here called select stuff. Could be select object, could be anything, right? Finally, again, remember this is version 2. This is kind of, this AST is kind of all passed off to some interpreter that I'm not going to go into because I simply do not understand how it worked at the time. But basically, my understanding is that the interpreter executes this AST kind of bottom up, right? You need to figure out what the variable expression on the right-hand side is before you can assign it, and so on and so on. Fairly simple, right? As I said before, in version 3, there's kind of a major refactor of how the entire language infrastructure worked. The language itself also got a bunch of new keywords. The tokenizer was refactored as well. But what's really interesting from version 3 and on is that the interpreter is now gone. We don't directly execute the AST anymore. What happens instead is that the AST is passed to something we call a compiler. This compiler is going to generate an expression tree. And this expression tree is it's a little bit like the AST, but it's a representation of the code that the computer, or rather the .NET runtime, can kind of figure out how to execute. And the reason for this, you could ask yourself, why add all this complexity? PowerShell version 2 seemed to work kind of fine, right? But my understanding is that with the introduction of this kind of compiler step into an expression tree, you can now pass the expression tree off to something called the dynamic language runtime in .NET, and you get a bunch of performance benefits out of that, because now you can let the runtime figure out what to cache and what to do in between, instead of just executing everything up front. In version 4, some more stuff gets added, right? DSC stuff. I don't know a lot about DSC, so I just put DSC stuff here, but I'm assuming there's something in there. And then something I actually have an understanding of, in PowerShell version 5 and onwards, we have this ability to define types, right? The class keyword, you put that in, and all of a sudden there's a new type in your runtime. The model is still the same. We generate an expression tree that the DLR can then evaluate at runtime. Again, this is an oversimplification, right? And there's a bunch of stuff that happens in between step 1 and 2. There's a bunch of stuff that happens after DLR evaluation. There's a bunch of stuff happening in between. If you want to get a better understanding of this complexity and everything that's involved in the abstractions and so on, last year at the European PowerShell conference, Dongbo Wang, who's a senior developer in the PowerShell team, gave an awesome talk where he basically ran through what happens when you press enter and up until the time that you get your result. He kind of skipped over this part, but he goes a lot into, how does PowerShell determine what to do when it figures out that you have an executable instead of a script, or instead of a function, or instead of a resource. So highly recommended if you think this stuff is interesting. Go onto YouTube, search for PowerShell Engine internals, Dongbo Wang. You're going to find this talk, and it's great. Right. With all of this in mind, we're now going to break out into 2 small demos. Let's see if I can find this here. Just going to duplicate the screen. Right. That's probably a little too small. Is this readable? Yeah, it's good. All right. So, as I said before, in PowerShell 3.0, the parser, this intermediary step that kind of does syntactical analysis of your script, is exposed to the user directly, so that we can get access to these ASTs ourselves, as some of you might have dabbled in a little bit. If you've looked at a module like PS Script Analyzer, right, this is basically what PS Script Analyzer does. It generates this intermediate representation of your script. It goes through it in a structured manner, and it says, you shouldn't be doing this, or maybe fix this, right? So there's a lot of tooling, there's a lot of editors that depend on access to this intermediary representation of your code in order to make some sensible decisions about it. The way this is exposed is via a class called Parser. And the way you invoke this is via a method called passFile or passInput. PassFile, you pass a path to it, or passInput, you can simply just put your script in here, right? So if we take something like 1 plus 1, actually, I'm just going to look at the signature of this. It's maybe a little wrapped, but basically as input, it takes the script that we're trying to analyze. It takes a reference to an array of tokens that it's going to return to us. This is what the tokenizer does, and then potentially an array of parser errors. So what we're going to do is we're going to prepare an array called tokens. I'm not interested in errors because I know that 1 plus 1 is a valid expression in PowerShell. So what we're going to do here, we're going to say 1 plus 1. We're going to hand off a reference to the tokens array, and then a reference to null, because I don't care about the errors. PassInput itself, as you can see, is going to return a script block AST. So we're going to assign that to variable AST. And you can see here, AST, okay, it It's a script block with an end block. Okay, it has an unnamed block in there, and there are some statements. I'm not going to go into how you can traverse this or how to implement AST visitors. Again, I'd strongly recommend you go back and revisit Thomas Raynor's talk from last year. There's a lot of good stuff in there. And there's also resources online. Other people have talked about this extensively. What we're going to look at is the tokens array. And so here we can see that, okay, we have some sort of token with a value 1. Okay, the tokenizer has recognized that this is a number. There's some sort of operator here with the text plus. It has a bunch of flags, binary precedence at, binary operator, okay? We have another value 1 down here, and then end of input. These are the tokens that the tokenizer recognized when we passed this script to it, right? So this all looks pretty good. If we look at, let me see here. If we look at the kind property, look at its type, we're going to see that it's, okay, it's a token kind. I wonder how many token kinds there are, right? How many distinct types of tokens will the parser or the tokenizer recognize? So if we do enum get values, keep in mind that this is the version 3 and up parser. Okay, that's a lot of token kinds. See, we have configuration workflows, it recognizes keywords, that sort of thing, right? If we do a count of this, okay, we have 150 different tokens being recognized in PowerShell version 5.1. If we did this in version 3 or version 4, it would be a little less because new keywords and language constructs keep being added. Now, it also exposes a version 2 mode parser called PS parser, and it works a little bit of the same, except this one does not actually expose the entire parsing routine. It only exposes the tokenizer. So again, if we want to know the tokens interpreted in the context of the PowerShell version 2 language, we can say tokenize, and again, kind of the API looks almost the same. It returns a number of tokens. It takes a script, and then it takes a reference to a number of errors. So if we try to do the same thing again, this is the version 2 parser, or version 2 tokenizer. Say 1 plus 1, and we give it another reference to null. I still don't care about the errors. And then I'm going to assign here v2 tokens. Okay, this is a little different from what we saw before. First of all, there are only 3 tokens here. It does not recognize end of input as an actual token. You can also see that we have a bunch more properties. It has like direct references back to where in the script this was entered, right? This is again very useful if you're writing an editor or a tool like PScript Analyzer that needs to be able to automatically remediate some things. Now, if we look at this type property, we see that it's a little bit different than the token kind we had before. And if we again try to enumerate all the values of PS token type, much simpler, right? We only have 20 kinds of tokens in PowerShell version 2. So again, this kind of shows that between 2 and 3, there's a massive expansion of not only the language surface itself, but also how the parser and the tokenizer interprets the language and the level of granularity that you get out of the kind of AST parsing step, right? All right.
Just a quick question.
Yeah.
When you're saying version 2, you're talking
PowerShell version 2, yeah, absolutely. I hope that was clear. Right, so what we just did was we hooked into the tokenizer that's being used for PowerShell version 2. The other one is PowerShell version 5.1, which is more or less the same in 3, 4, and 5, and 6 for that matter. All right. I'm just going to switch back to... Is this going to work? Nope. As you can see, I'm not a PowerPoint super user. All right, so as I said before, now that we have a very basic understanding of the language runtime infrastructure itself, how all of this parsing nonsense works, and that there were some changes throughout the versions of PowerShell, okay, let's dig into the meat of this talk. Wouldn't it be cool if we could start modifying this behavior ourselves? Wouldn't it be cool if we could take PowerShell Core, in which we can edit because we have the source code, and we could introduce our own new operator? And so what I thought would be cool today was, I know that there's an open issue on GitHub. I couldn't find it this morning, but I know that there's an open issue on GitHub for implementing containment lambda operators. What is a containment lambda operator? It would look something like this. Just like with the -contains operator, you have some enumerable input that could be an array on one hand side. Then I chose to call this any. And basically, the behavior is the same as with contains, except that we now have a script block, right? We have a lambda function on the right-hand side that'll be evaluated against every single piece of input on the left-hand side. And if any of these hold true, hence the name any, we're going to return true. If not, we're going to return false. And so this could be really useful when you have, sometimes I see anti-patterns like nested where statements, because you need to figure out, is there like a single thing in this collection that satisfies a condition for an object that contains this as a property? And so people do nested where loops with contains all over the place, and it gets really slow because you then need to iterate over the entire thing in order to execute your lambda against the input arguments. Right. So what I want to do now is I want to switch into Visual Studio. I know that VS Code, I think, is like the supported development environment for PowerShell Core, but I'm more comfortable in Visual Studio, so we're going to do that. It's my talk anyways. And hopefully, by the end of this, if I can move fast enough, we will have a working any operator in PowerShell. So we're going to do that. So I have two main tools here. Could I use PowerShell Core as well? This is just oh. Thank you very much. There we go. I'm just going to increase the size of this a little bit. Right. I'm basically going to use only two tools. Can you all somewhat read what's up there, or do you want me to buff it up a little bit? Bigger. Yeah? Bigger is better. Like this? Yeah? Okay. So we're going to use two tools only. We could have used PowerShell Core for this. I'm using PowerShell 5.1. Doesn't matter. Basically, I need somewhere to run the build scripts for PowerShell. That means when we go in and we make a change to the C# code that makes up PowerShell, we need to be able to recompile the pwsh.exe. We're going to do this from here. The only thing I've done is I've imported two modules. I've imported the build.psm1 module that ships with PowerShell. If you've never built this before, or you just cloned this GitHub repo, you will have to run, I think, start ps bootstrap, if I can type, which will download all the dependencies, make sure that you have the .NET CLI installed, and so on and so on. Once you've done that, you can basically do start ps build, and it'll start going through all the projects in the PowerShell solution and compile them one by one. Given that we're only going to be touching system.management.automation and not all the other projects, there's a switch in here, SMA only, so we kind of skip recompiling all the other projects in there, and this is probably going to be good for the timing of this talk. Right. So the only thing I've prepared is a list of notes. A couple of months ago, I said to myself, I should probably prove that I can actually do this before I go up and embarrass myself on stage. And so I wrote down all the changes I made to make this work. And so we're just going to start with there. If we look here, I think it might be a little small, but over in the navigator over here, we have this project called system.management.automation, the core of PowerShell. Down here, there's a folder called engine, and then there's a folder called parser. And basically in here lives all the code that takes care of parsing and tokenization, all the lexical analysis steps for the language. The first thing we're going to be looking at is this file called token.cs. Token.cs contains the definition of the token kinds, the 150 different types of tokens we looked at before. They're all here at the top. It has some token flags. You saw the binary precedent, so on and so on. And I think if I put this out here, it has a number of other metadata types for these tokens that the tokenizer is going to produce. So if we go down and we look at token kind, and there's a section here called operators. These are basically the operators that you already know from PowerShell, right? And someone has been nice enough to put in comments here saying, like, this is the actual operator that we're using, right? So the pipe symbol, for example, results in a token kind called the pipe. That kind of makes sense. Minus for decrements, so on and so on. If we go down a little bit, we get down to the end. Down here. And you can see there's a gap here between the value of the colon token kind and the next one, which is the keywords. So we should safely be able to define some new token kinds in here. So we're going to implement the any operator. So we're going to call the kind of token any. We're just going to give it the next consecutive value. Now I'm going to get an error because there's no comment-based help. Solved. We can fill that in later. Right. The next thing we want to do in here is we want to update something called the token text. And down here, there's a static array of strings that needs to map one-to-one with the token kinds. And so if we go down here again, what is the text for the operators? And this is basically the mapping between what you see in the AST and the actual symbols that you have in your script, right? So again, if we go down here, down by the end, the last one is colon, and there's a bunch of reserved slots. Great, we're going to take one of those. So this is for the any, just so we can keep track. And as I showed on the slide, the token text for this is just going to be -any, just like dash contains or dash EQ, for example. Right. The next thing that we need to assign to our any token is some token traits. This is going to tell the parser something about the behavior of the token itself. What is the precedent? What kind of token are we working on here? Once again, go down to where we left off. Colon reserved slot. We're going to take this. Excellent. Now, what we're going to be implementing is going to be a lot like contains. So I have no idea how any of this works. I didn't design the language, so I said, let's look at how contains work. Turns out that contains is a binary operator. It has binary precedence comparison, whatever that is, and then it's either case sensitive or not. Our any operator is not going to be case sensitive, so we can do with the first two. So we're going to do token flags binary operator and token flags binary precedent comparison. All right. Now that PowerShell knows of this new token type, the -any operator, the next thing we need to do is we need to tell the tokenizer, the thing that produces the tokens, how to actually produce them. So again, we need to map the text -any to some sort of routine in here. As far as I remember, it's something like operator text. Yeah, here we go. And again, here we have two tables that need to be aligned. That basically maps the kind that we just introduced and the name itself. So down here, let's see, these for keywords. All right, so here at the end, we're going to add any. This is the name of the operator, so notice that we don't need to put a dash in front, because the tokenizer will recognize a dash, and then it'll look for one of these strings after it. Finally, we need to map that to the token kind that we just introduced. And so again, keeping everything nice, we're going to do token kind any. And you can see here in Visual Studio with all of this nice IntelliSense completion, it already pops up because we added it to the other file. Right. So now that we have this tokenizer infrastructure in place, I don't know if anyone noticed, but since this is kind of a crash course, this is also a lesson in what not to do. And obviously, I should have written a bunch of tests for this before I started. We're not going to do that, but lesson learned. What we're going to do instead is that I've saved my files. I'm going to go back into PowerShell, and I'm going to run start.ps build SMA only. What's going to happen is that I'm just going to close this down. What's going to happen is that it's going to recompile system.management.automation.dll with the changes that we just made. And so if we run the compiled version of PWSH, we should be able to have it reflect the changes we just made. So again, as you can see, there's some dependencies. It takes a little bit of time. It used to be an old joke that if people weren't doing anything, my code is compiling, right? This is kind of why it's nice with this SMA-only thing, because otherwise a bunch of other stuff would have to compile in the background. Now that we're done, we can do get ps output. It shows us the path to the binary. I'm just going to copy this. I'm going to launch it. And then I'm just going to update my prompt. And now, if we do, we're going to do just like we did before, the current version of the parser. We're going to call pass input, and then what we're going to do is we're going to say our example 1, 2, 3, any. Right. So before I compiled this, none of this should have been recognized by PowerShell, right? -any is not a PowerShell operator. So we want to capture some errors in case there are any. Capture the tokens as well. And now we pass in a reference to the tokens array, exactly the same as before. And we don't care about the AST right now. So now, if I look at tokens, what we're going to see up here is that indeed it recognized -any as an any operator with these token flags that we just gave it. Okay, so far so good. You haven't broken anything yet, I think. There's still time. Excellent. All right. So now that we're done with like the first part of what we saw before in the language infrastructure, we can tokenize these. You might be asking, so the rest of the parser, does it need to do anything? Well, it doesn't actually need to do anything because the parser recognizes this form. You have two expressions, and then you have like a recognized binary operator in between. It recognizes that this is what's called a binary expression. And so the parser already know what kind of expression we're dealing with here, and so we don't actually need to do a bunch of stuff in there. The only thing we need to do is we need to jump to the next step, which is the compiler. Again, the thing that takes the AST that we just produced with our new tokens and turns it into an expression tree that we can execute. So in here, as I said before, the parser will recognize that this is a so-called binary expression. Had we looked at the AST, we would see that it would be a binary expression as well. The compiler is implemented as a so-called AST visitor. It's kind of a tree traversal thing that goes through the entire AST and inspects everything and does everything that needs to be done. And so if we go down and look for the method visit binary expression, what we're going to find down here is that the binary expression AST is going to be passed to the compiler. The compiler is going to do a bunch of stuff that we don't care about. And then it's going to have a look at the operator. And so down here, you can see that the operator it's a token kind, right? So okay, we're kind of in the right ball game here. If you look down here, yeah, you have the plus operator, the minus operator, so on and so on. Since there's kind of a closeness to the contains operator, we're going to see if we can find that. Down here, we can see whenever it encounters -contains, it's going to return the result of generate call contains. I wonder what that is. We're going to find out in a second. What we're going to do here is we're going to add another switch case so that the compiler now recognizes that if we pass it the any token, it should do something else. Namely, it should, let's say, generate call any. And again, since the interface is kind of similar to contains, I'm just going to assume that it's going to look something like this. We're going to have to pass in the left-hand side argument, the right-hand side argument, and then what do we have here? Ignore case, right? We don't care about casing. So LHS, RHS, and yes, it's case insensitive, right? The next thing that we need to do is we need to go into a file called Parser Utils. Parser Utils contains a number of the actual implementations of what happens when your code executes. So we need some way of binding what happens in the compiler to a function that will then give us the result that we're expecting from -any. And so if parserutils.cs, if we go down here, let's see if we can find that generate here. So here we can see, again, I'm kind of using contains as a reference point because, again, any is going to work almost like contains. So what I'm going to do here is I'm just going to steal all of this. It's open source, it's fine. And we obviously need to rename this. Any operator compiled. Now, since this says contains operator compiled and not just contains operator, it might be that some other function in between is calling this. Again, this is why I'm using Visual Studio. The code navigation tooling in here is kind of superior to VS Code. And so if we look here, contains operator compiled, if my touchpad works, we should be able to see where this is called from. And down here, this class right here is called cached reflection info, and this is basically kind of a convergence point for all the operators and their behaviors in the compiler. Basically, you pass it a reference to a method to be executed as part of the expression tree rather than executing the method itself. And so here we're going to add our new, we're going to add a reference to our new method. We're going to obviously call it any operator compiled. And again, we're going to reference the method that we just copy-pasted from the contains operator. All right, with that in place, we can go back to Parser Utils. And now let's take a look at the actual implementation here. What is going to happen when the expression tree executes? So this is now just the contains operator, right? It's going to go through and see if it can find a result in the collection that matches the right-hand side argument. And so, see here, it turns the left-hand side argument into a list. If that is not possible or the list is non-enumerable, then it's just going to do a single scalar comparison, right, like 1 = 1, and then return immediately. Otherwise, it's going to loop over every single object in the list that was passed in. It's going to try to make a comparison, and then it's going to return true if that's the case, right? If the array at any one point contains the thing that we asked for, return true immediately. Otherwise, if we reach the end of the list and we haven't gotten a match yet, you return false because then the list doesn't contain what we're looking for, right? Now, this is where it gets a little tricky because doing a simple comparison one-to-one, okay, it looks a little complicated, but it's a single call and a cast to a Boolean, right? What we need to do now is we need to take a right-hand side argument that's a script block, and we then need to execute that against this entire list. And because I can't remember all of this syntax in my head, I've cheated a little bit like they do on TV when they cook. And so, if I can find it here. So, some time ago, I already implemented this, and I forgot to connect to the Wi-Fi. All right. Does anyone know what the password is? Excellent, excellent. work very well. Oh, here we go. No, I switched laptops last week and I haven't cloned all of my branches. This is terrible timing. There we go. All right. So if we go back here, try to browse GitHub. Right. And as I said, I cheated a little bit. I did this from home. And so basically what I did, if we browse this file, what you can see down here is that basically I take the right-hand side argument, I try to convert that to a script block, see if that fails. If that fails, I'm just going to assume that it's a scalar value that we're trying to compare against, and I'm going to default to the contains operator. So we're going to take this. I'll go through it in a second. We're going to replace this implementation with this. And so here you can see, as I said, I try to cast the right-hand side argument to a script block, and if you pass in a script block or a PS method or some other type of predicate, this should work. If that's not the case, I'm just going to default to a normal contains. After that, we're going to do the exact same thing. We're going to try to turn the left-hand side argument into a list. And then what I've introduced down here to reduce or to reuse some of this code is I have a function up here. If I can find the right place. Up here, I'm going to define a read-only call site. This is all very confusing. I don't understand how it works, but this is basically the way you implement caching on behalf of the expression tree so that the DLR can make some optimizations for this. Again, what we're going to do here is the call site is going to point back to a so-called PS-convert binder, and the effect of this is almost the same as casting to a Boolean, right? So you take some result, just like in an if statement or a where operator, and then by the end, you try to convert that to a Boolean, it's either true or false, right? So we're going to do the exact same thing with this method. And as soon as I do this, if we can get back to our any operator, this is the final step, right? So just like before, we're going to move through the list. And then instead of doing a comparison, we're going to take the script block that we just created from the right-hand side argument. We're going to call do invoke return as is. And the reason we're calling do return invoke as is that this is a way of injecting $_ into our Lambda. So that means that for every input argument that we run against this Lambda function, this script block, $_ is going to take on the value of whatever we just passed into it. And so this is the exact kind of magic that you see in with where object or in pipeline bound variables. And then finally, we convert it to a Boolean, and the logic is the same, right? As soon as we hit a yes, we just want to return immediately because we just want to know if any matches the criteria. So let me see if I got this right. So we're going to compile PowerShell once more. It failed. All right. Right. I forgot this mapping between the generate call any in the compiler and then the actual function that we just implemented. Again, because I'm terrible with remembering where these things need to go, I'm just going to cheat a little bit again. And as you can see down here, I have a single method that generates the actual expression from that call site. I am going to add that in the compiler. So we're going to go back, generate Great. Call contains. Put it right next to. And I think we used a different name for this. Parser ups any operator compiled. Again, instead of executing the code right away, we're going to return an expression that would in turn call our any operator function that we just implemented, and send the left-hand and right-hand side arguments to that function. So we're going to save this again. We're going to compile. Seems to work. All right. Copy this again. And now, for the big experiment. This is the example I gave in the presentation, right? You'll notice now that when I use the -any operator, PS readline no longer screams at me. There's no longer any parser error, so that's already a pretty good sign. $_ modulo 3 equals 0. And it returns true. Now, I could have cheated, right? I didn't write any tests for this. But let's do a very simple heuristic test here. I'm going to remove the only element in the collection that satisfied the condition. And now it returns false. Let's see if we can start from here again. Right. So conclusion, again, this is just me hacking on PowerShell because I think it's fun, but also because I like working on the issues in GitHub. And if you thought this was fun, maybe this will be a gateway drug for you into getting a little deeper into the engine of PowerShell as well. I don't have any philosophical conclusions or takeaways from this other than PowerShell language infrastructure is complex, but it's actually kind of typical. If you go to a kind of modern programming language compiler's course at your local university, you're going to see a language infrastructure being doled out kind of in the same way as what we're doing here. There's obviously some changes because this is a highly dynamic language. So yeah, there is some complexity, but it's not atypical for this type of language. Super fun to play with. Open to anyone. I have no idea what I'm doing. And so yeah, go build your own operators. You got this.